Okay, so the majority of what we're going to talk about today is around one of our newer architectural design patterns for the cloud. So it's by no means Azure specific, but we see it quite a lot in Azure implementations nowadays. And the idea behind the pattern as it was presented, I'll go through a couple of common trends that we're seeing in and around the user experience when people are onboarding services into cloud, some of the user expectations that yet led to this design pattern and its implementation. I'll walk through some of the things that can occur if you decide to do a geo deployment, and then I'll finish with a sample demonstration of an implementation of the geode pattern, which part of it is pre-prepared, so you'll be able to go and interact with it if you want to as well. So I'm not going to ask for audience participation, but as you see the URLs going through, none of this is pre-recorded, so it may go disastrously wrong if my laptop also ceases to play ball today, but hopefully the thermal throttling I've been experiencing will calm down a little in the heat. But let's go along and see how we get on. So none of this is pre-recorded. All the URLs you're going to see will be active, and we'll actually be doing a deployment during the session. Okay, so firstly, I said we'll talk through a couple of our common trends that we're seeing, things that led to the requirements for the geode pattern to be published. And the first one up is customer non-functional requirements are getting increasingly more challenging. So as customers, you will all know this. Those of you who are deploying services into IT, your user expectations are getting higher. Those of you who are building out services, if you're an ISV or a solution provider or partner, you will also be seeing your customers' expectations as a result becoming higher. So those things around the non-functional requirements around the performance envelope, low latency, high availability, and high level service level agreements, these things are not getting any easier as we go. I'm going to talk about a little bit about, and I'll go into these in more depth, around what we call about near edge and distributed compute. So this is one of the things, again, bringing compute to the data rather than bringing data to the compute. Talking about what starts to happen with geo-distributed systems and the kind of things you'll see, what kinds of services we can use, and we'll talk a little bit about edge acceleration and some of the technologies that we can use there to bring the geo pattern to life. So kind of point one around customer NFRs being more challenging. It is not uncommon for us to be seeing 4 or 5 nines in service levels now, with high availability recovery times in 10 to 20 seconds with 0 data loss, with a service that requires end-to-end latency of less than 250 milliseconds inside processing. We are seeing some customers come to us with data requirements for single-digit milliseconds globally, which up until best part of a couple of years ago was just impossible to do. There was no cloud platform that could actually do that. So we'll talk about how we can get through some of those challenges, what things we can do, and how we can evolve to kind of meet the requirements that you can see here with very, very dynamic scalability. And then we'll talk about how you can actually look to kind of drop your budget by using modern serverless patterns inside the geo pattern. So I'm not going to demonstrate serverless today, but I will point you to a repo that actually has a pretty slick but quite complicated demonstration of a real-time messaging and voting system, which is based on Geode. It's quite complex, so I don't really want to demonstrate that to you today. What I have is a simpler but more typical kind of Geode use pattern. Okay, so what do I mean when I talk about near edge or near compute? So one of the things that we are increasingly seeing demand for is far-flung compute. So this diagram is relatively old. It's from a presentation I did out in Ireland about a year and a bit ago before lockdown. And this shows a series of regions that actually had the Azure Function service available in a serverless consumption manner. And as you can see, it's the majority of the Azure regions there. In terms of regions that are not present here, you can see there were 2 new announced ones. I think UAE does have it now. China's technically a separate cloud, so we wouldn't represent it on there anyway. And South Africa West is a backup region. that's available to users already in South Africa North. So that's the reason for part of those gaps. But effectively, you can see we've got quite wide-ranging coverage there of the services where you can pick up service compute and place it near to the edge of your users. So in terms of the serverless technology that you can see, so one of the really nice advantages of working with the serverless stack, or well, when I say serverless here, I'm actually talking about consumption-based billing, and that's really what I'm referring to, is you can deploy more than one instance of your compute, and the risk for the cost base is that rests with us, not with you. So you can deploy into region A and into region B at the same time, and if you're charged based on consumption, you're only charged in the consumption region where you consume the service. So if you had, just taking it as an example, if you had 2 million requests distributed across region A and region B, you're charged for 2 million requests, yeah, regardless of where they execute. So you can effectively add additional regions for free for no extra cost, because you'll be charged for 1 million in region 1 and 1 million in region B. And that then leads us into a data type pattern. So what happens if we think about that, not just at the compute layer, but at the data layer as well? And the price model for this looks a little bit different, because Cosmos in particular, which is the iconography here, isn't consumption-led pricing. So, but we can do geo-distribution at that level as well. So we can distribute the load of the reads across multiple regions. Yeah, so and the trick there, of course, is you generate a lower capacity. So if I have 10,000 Cosmos RUs and I deploy 5,000 to each region, then I end up with half that distribution. And as long as my distribution of load is roughly even, that's actually going to cost me more or less the same. And then we can chain those together so they replicate to each other, and half of our regions users are distributed to region A and half go to region B. And the backplane connects the dots for you. One of the other concepts I'm going to talk about very quickly when we come into the technical data of the pattern is singleton change tracking. That's something we talk about in the geode pattern. It's not mandatory for geodes, but if you do geodes with Cosmos, this lights up a specific feature, which I'll come to shortly. But effectively, the idea of singleton change tracking is if I want to have I can have a service which can, say you're following an event sourcing pattern, which is for the non-developers in the room, event sourcing is when I simply store a series of events in some kind of store. Could be a database, could be blob storage, and I'm always replaying them forward only effectively. So I have an append only store of events, which creates my data store. Now I can read that series of events to reconstruct the state of an object or reconstruct the state of a given entity at any time that I want to. In a geode, we have the data is replicated across all nodes, across all geodes. So actually, we can replay that object in any particular place that we want to. So if I'm in Australia, or if I'm in the UK, or if I'm wherever I am, I can replay that state locally. Now, I'm going to give you a bit more detail behind that, but there is a feature within the Cosmos SDK effectively when used with functions around leasing to a given location. And that allows us to ensure that if we want to track a change and execute something, say like counting up and adding something to an aggregate in a data model, we can only do it in one place. Or at least it can happen in any of a set of given places, but it will happen only once. Hence the term singleton. But that leads to some very interesting features and flexibility, which I'll come on to later on, which may not be immediately apparent when you think about what we're doing here. Okay, so we have a write that goes away to region A, and we can read from region B, and actually then our function only lights up in region B and not in region A. Or we can do the inverse, and we can say, actually, we don't just want to see this in one region, but actually I want to be able to write to both regions, and I want these both to pulse, and I want them to be picked up in both regions. And then that acts like a geo-replication, invoking our compute in both regions. And effectively what we would be talking about there, if I had an instance of my service running in West Europe, and I had one running in Australia, and I tie my tie an Azure function up to a Cosmos change feed, then for every record that gets added to the database and the collection, the Cosmos function will fire in both regions or in all regions simultaneously. So we can use that to generate localized stores, or, and I'll show you this a little bit later on, we can use it to do, for example, coordinate messaging. If you need to notify users in different regions of different things that are happening, or all regions at the same time, even though they're connected to different services, you can choose to do that. Okay, so I don't know if we can do a show of hands on Zoom. George and Charlotte, please stop me if we can do that. But I'm going to kind of ask and continue anyway. How many people will have used the front door platform? Well, Charlotte?
I think you can raise a hand. Yep, there we go. We've got a thumbs up.
Okay. So I can't see that, but if somebody could let me know how many we actually have. So please, thumbs up if you've used Azure Front Door as part of the Azure platform before.
We've got two.
Daniel. Okay, so not as many as you might expect there. Okay, fair enough. Okay, so I'll give a quick 2-minute preamble on what Front Door is, because I'm going to use this as part of the demo. So Front Door is globally available layer 7 proxy. So there's a couple of features. I'm not going to go into the feature set. This isn't supposed to be a sales presentation, but basically you can think of it as a global array of application gateways and web proxies that are designed to do both CDN type caching and dynamic network acceleration. So we can have a series of backends. Let's say I have, for example, in my demo later, I will have 5, which are located in different places around the world. And Front Door is capable of probing those and routing your user to the nearest one via a transparent proxy. It handles a pattern called split TCP. So what it will do is it will terminate the connection's SSL near to the user on our nearest point of presence. So for Azure, for example, in the UK, that's likely to be either a POP in Manchester or at the main DCs in London or possibly Cardiff. Now, we don't necessarily disclose exactly where they all are, but you can be assured that there will be one pretty close to your users, regardless of where they are in the globe. But the idea of that is that the round trip time is dramatically reduced. So the connection acceleration on the back ends is quite clever in terms of what it does. And if you combine that with the near edge compute pattern I was mentioning earlier on, then you get to a stage where you have connection acceleration combined with compute near to the end user, and you can pull data near to the end user. And combining those three together gives you some really quite compelling patterns, one of which is, of course, Geode. Okay, so we have another kind of network service that you can use, which is if your services are not web-based. So although I think Front Door is amazing, it won't do acceleration or routing for anything which isn't HTTP based. So if you choose to use Traffic Manager to route, you have more flexibility in the different types of traffic routing options. And Traffic Manager is DNS based, so you can choose to flip to you can flip to region A or region B based on weightings or performance or round robin, or you can just return all the IPs if you want, let the client choose. And you can do that for any connection rather than just HTTP, because it's not a traffic proxy. Okay, so we hit and then we get routed directly to the backend endpoint, regardless of what that is. Now, a quite interesting pattern is to combine Front Door and Traffic Manager. And I'm not going to labor this particular point. I will come back to this in a moment when I've got a better diagram on screen. But in particular, what this pattern does is if you layer Traffic Manager and Front Door, what you'll do is Front Door will connect to Traffic Manager to determine the nearest endpoint for each region. Rather than just probing them all, it will probe one endpoint as far as Front Door is concerned and will resolve that to the near edge. So I think you can see my mouse on here as well, hopefully. But my user here, nearest to region B, goes in via a Front Door endpoint. So this is the edge pop. The edge pop brings me into my main proxy backend, which is looking at Traffic Manager. And then with the edge pop, Traffic Manager resolves the nearest region. And effectively, then front door proxies me to the nearest region. Region A, we hit front door, and the same thing happens there. And that's subtly different from that configuration where my end user hits traffic manager and is actually just resolves the DNS of the base region and goes that way and connects directly. Or this configuration where I come in and just hit the nearest endpoint regardless that front door happens to have probed. And the key differences are around probe timing and around probe load and fast failover. But I'll come to those in a moment when I actually demonstrate how those services work inside geodes. Okay. So any questions around the kind of baseline technologies that we have, that we can use, that we can pick up before I move into some more kind of vertically aligned and specific stuff around geodes? Please feel free to bang them in the chat window, or again, raise a hand, and the moderators and consultants will stop me if they need to. And if there are no questions, I shall carry on. Okay, so the base of what you're all here for now, right? What is actually a geode? What do we mean when we say geodes? So if we can do another thumbs up / show of hands, how many people have looked at the geode pattern up on the Azure Architecture Center?
We have one thumbs up.
We have one. Okay, for that one person, when you looked at it, did it feel complex or simple when you read the document actually on the Architecture Center that describes what geodes is and where they might be used? You need a thumbs down icon, Richard. Yeah, I'll assume everyone who doesn't thumbs up would not have heard it. Okay, so the one thing about the geode patterns is they're actually very, very simple concepts, but when combined together, they're quite powerful. And when we were putting this documentation together, it's remarkably difficult to explain what a geode really is. And it's a play on the phrase geographic node. So the geo from geographic and the DE from the back end of node. And the idea is when we have a compute node or a storage node or whatever else, those tend to be co-located close to each other. Yeah, so for latency and performance reasons, those tend to be near, and we tend to place the tiers of applications close to each other for latency. And the idea of a geode, or rather multiple geodes, is they consist of a collection of types of resources that are co-located close to each other and are cookie cutter stamped around different geographies. So we have a collection of services in region A, which are the same as another collection of services which are in region B, which are the same as another collection of services in region C, and data is replicated across all of them using a replication backplane. And then there is some kind of traffic routing or edge network acceleration technology being used in front of them to present all of your geodes globally as a single system. Yeah, so everything should be self-contained. The only thing which, if a geode fails, so let's say there is some kind of natural disaster and the entire region is offline, then a geode-based system should be able to survive the loss of an entire region and continue to operate. So no geode should be dependent on another, and shared components should be globally fault tolerant. I'll come to that a little bit more, but you'll see the key point on the next diagram. This is an example of a possible geode service. And we have a nice animation on here, but this kind of cloud that you can see is actually the activity probes. This may not necessarily come across that well on my screen share, but what you should be seeing is from each one of those kind of the triad type pointy nodes, which you can see here. And these are your front door points of presence. And what they're doing across the front door endpoints is they are probing each of these geode nodes. Yeah, so we're exposing external nodes here in these 4 places as the ingress point into each geode. Yeah, the technology we've used in here, so you can see functions in here. You can see API management and storage. It's not necessarily that important. I mean, the demo I'm going to show you today doesn't use AppIm, and it doesn't use functions. Yeah, it doesn't use SignalR either, which is this icon. And in this case, actually not all geodes are equal because SignalR is present in some regions and wired up here. But you can ignore SignalR for the purposes of what we're describing today. But what is important is what they all do is the same. Yeah, and a geode should be kind of born equal. Each user is going to come in from here. So let's say I've got user A here. They come in, hit the edge of the load balancer, and they are then going to be proxied across to this endpoint, which is going to hit a common data store, which is geo-replicated between these instances. So all of these services should behave in exactly the same way. Yeah, and effectively the reason for this piece here is because we're showing it's a mesh. Yeah, so there are over 150, I think, in terms of the number of POPs we've got. Yeah, and the one disadvantage potentially to doing this configuration, yeah, so if I've got 4 geodes, is you get a lot of probe traffic. So you can see that from the mesh here, right? Each one of those AFD POPs globally is going to probe each one of your backends. And if you've got 10 geodes or 40 geodes potentially, then you're going to get 150 probes at least a second per backend. And that can rapidly add up to quite a lot of traffic, especially if you're using consumption-based services. So there's a variant of the pattern here, which is what I mentioned earlier on, which is where you basically point front door's back end at a traffic manager profile. And I'm not going to demonstrate this today, but it is up on the repo I'll send you to. And then each front door only sees the traffic manager profile as a backend. And it also gives you some more sophisticated options in terms of how you want to route the front door traffic. Because as far as front door is concerned, it only sees one backend. And then you don't need to actually have all of the front door probes running. We just have the back end probes from here. So in that situation, that's that diagram I showed you earlier on. My user here connects into front door. Front door has resolved this IP. And what actually happens is front door connects directly across to here.
We have got a couple of questions in the chat box for you, Will.
Shoot.
You mentioned replication in the backend data. Does that mean that they can't be transactionally consistent?
That's a great question. Without getting into mathematics and Brewer's and Cap theorem, they can be transactionally consistent, but at the expense of performance. Yeah, so if you want to halt a transaction of an insert until the remaining commits have been executed within, in particular we're using Cosmos here, then you can do that. But actually that has an impact on service latency for inserts. It doesn't have an impact on service latency for reads. And 90% of workloads that we see using this are very, very read heavy with very few inserts. I'll come to the second question in a moment. Okay. But you have to trade off something in a geo-available system. And the majority of the time, what people explicitly choose to trade off is that transaction consistency. So in terms of the replication backplane, what we're not showing on here is we're not showing that in the configuration I'm going to show you, one of these regions is handling all of the writes. And it can be any one, so the configuration is the same. But in the Cosmos service, one of them will be writable and will hold all of the writes from all of the regions. In extreme situations, that can lead to things being slightly unbalanced. So it's not an optimal configuration. If you choose to do multi-write, so in the Cosmos backplane, if you have all regions being writable, then what you do have to do is you have to have a lock resolution mechanism. So if I get a write conflict, what do I do to resolve it? Because it's physically not possible to execute the same write without locking transactionally in more than one place in the globe at the same time. Now, 99% of the time, that isn't an issue because your users generally will only be in one place. And normally with writes that are user optimized or location optimized, you'll start to see this kind of follow the sun pattern for user data. But it's not mandatory to do that as part of geodes. So if you have users that are working on the same piece of data from different areas in the globe, you absolutely do need to think carefully about what that means transactionally for your application. But it doesn't mean they can't be transactionally consistent. Does that answer your question? I think that's Richard. Okay, so I'll move on to the next question. So from Duchant, signal R is missing from D and C. Yes, you're right. And that's an error. Yeah, so if I go back one, basically I've removed them and I've forgotten to remove it from Geode A and B. So this is a reuse of the slide, which is actually up on the Geode pattern itself, up on the Architecture Center documentation, and that's a mistake in the other diagram. The original sample for this is a voting application that does a backplane call out using signal R. And I have basically forgotten to remove it in that first slide from two of the buckets. Okay, and for Mustafa, what if you can't replicate the Cosmos instance due to some regulative issues like GDPR? Is it possible to implement those? It is possible to do that. That's where we start to get to the stage where you have geodes which are based in availability zones or within a given geopolitical region. So there's nothing that says you have to have more than 2 geodes, right? We usually expect 3 for like a quorum type scenario, because then you can lose 2 and the service can still auto scale and stay up. But there's no reason why you couldn't have 2 European EU-based geodes or 2 UK-based geodes or 2 US-based geodes and combine it with another pattern in the Architecture Center called deployment stamps, where you have one geographic load balancer, which is routing to all compute, but your data inside the geode hits effectively a nested type configuration where it calls out to another microservice to get its data. The scope of what you would do there is probably outside the conversation that we want to have here, but yes, it is possible to implement such an architecture. It is very possible. The question is, how do you want to address that backplane and whether you should have centralized databases? Do they introduce a single point of failure? Do they introduce a performance bottleneck? But you can absolutely control replication by structuring your Cosmos or non-Cosmos data cleverly in the backend. The trick really with that, the majority of our services will do read replication in Azure anyway. So storage can do, Azure SQL Database can do, but they usually have single write capabilities. Only one can be a writer at any one time. If you have stamps for data, then you can set that out and you can kind of reduce the attack surface by having multiple groups of services that can fail over together, which could be, okay, my writer is here, my writer's here, sorry, here and here. But when I fail over these services collectively using maybe something like SQL failover groups. But ideally, your data plane needs to be in more than one place. And we're using the example of a region here. It doesn't have to be a region. It's an individually addressable place. So that could easily be an availability zone. Yeah, it could, in theory, if you're comfortable, even be a Azure availability set. It really depends on the impact of an outage and what your attitude to risk is to be likely to be. Okay. So moving on next. So what it looks like for a user's perspective if you're using geodes. So if we take away the configuration of all of our load balancer data, and we have some users sitting here, and our users are being pinned to the nearest node by AFD and Traffic Manager. The semantics of how we actually do that are not that important, but my user comes in and they hit one of these points. So they hit one of our AFD pops. Because we're combining AFD and Traffic Manager, AFD will already have the DNS cached for Traffic Manager, unless the TTL expired from the last request. In that case, it'll look it up again, and it will proxy directly to the endpoint, which in this case is Appim. Yep, Appim will fire into functions and will write the data away, and will obviously write it to Cosmos in Geode A. Geode A will, over our backbone then, for low latency, connect out and send that data into Geodes B, C, and D. So at that point, a simple write is complete. But actually, what we might choose to do here, and this is the clever part of this, is we might choose to be performing write operations locally to reduce inter-region traffic. So we might say we want to maintain an aggregate, or people in region might be interested in only part of that data. So Geode B might have something very, very specific that it wants to maintain about Geode B. So for example, a voting application might keep a count of votes that it's handled. Yeah. And as long as the code is the same across all geodes, the data that sits inside the region and gets replicated will be good enough. So then we can send messages back to each user from each space. Now that was the use case of Signal R that you saw here. So the illustration on this diagram is to send data back to each region. Obviously, Appim is not going to reach out individually to a direct user without having a direct messaging channel open. But normally what will be happening in there would be you'd have a user in here that's either polling or has some kind of WebSocket open to receive inbound connections coming back from each geode. But the key point here is that geodes can communicate with each other using the backplane of Cosmos to stream data to each other. And that can be, if I'd drawn this diagram with only one up arrow from here, if it only had one of those that fired this call and there's only one green line here, that would be an example of that singleton mode I was describing earlier on, where although all of these are identical, clever use of a least prefix in functions means that we only fire in one region. Yeah, this code is here, it's active and it's present, but we choose to distribute the load across regions, or we choose to align load in a given singleton region. Okay, so how are we doing for time? 47 minutes. Good, we're okay. So let's move on to a quick, well, I'll say fairly quick. It will be in kind of, we can expand it to fill the time available, but I do want to leave some time for further viewing and more questions if they hit at the end. But I want to give you an example of a service, and I've tried to keep this not too contrived. So it is a real world sample. You can go and download the code and you can implement this if you want to. No problem. There are the appropriate scripts and the codes present. I have also taken some of the features from the downloadable code, which does authentication, other things out as well. So you can interact with this demo for the duration of what we're going to do here if you want to. But you can see on here in terms of the different regions that we have highlighted, I'm going to have a geode-backed API that you can call, which will be present in Western US 2, in UK South, in Central India. At the moment, it isn't present in Central India, so I'm going to deploy it to Central India, in South Africa North, and in Australia East. And then we're going to show the use of the load balancer, and we're going to show the use of Cosmos to get that kind of that backing service running. Okay. Okay, so here is a very, very, very simple API. Yeah, and all this API does is it's going to return a setting that is present inside my service, just to prove that these can be different instances, right? So the first thing is to prove that there are lots of identical instances of this service running, and the only difference between them is literally there is a setting present inside my web applications that we can see are deployed 4 times to those locations. And if I go into here and take a look in configuration. So for those of you who are not necessarily that familiar with Azure and App Service, configuration settings in here override settings in configuration files that you choose to apply, and they get basically dropped in as environment variables. And so sitting inside Geode app AUSE, there is a setting called Geode name, which returns AUSE. So this is the Australia East instance. And then we've got RSA, which is South Africa North, UKS, which is UK South, West US 2, yeah, which is USW2, and the corresponding app service plans. In terms of shared components, we have a Cosmos account, so Geode Demo Cosmos. By default, they're homed in a region where their metadata resides. It gets replicated to all regions. The failure of UK South won't take this out. It will just fail over to another region. And the front door service itself is global. So let's take a quick walk through this kind of architecture end to end and show you how this is implemented, because these are the fundamental building blocks. It doesn't really matter where you host the API. It can be in functions, it can be an app service, it can be an AKS, Azure Kubernetes service. If you wanted to, you could put it in Azure Spring Cloud in each region, if it was a Java Spring app. Or you could put it in container instances if you wanted to, or you could even host it on plain VMs in IIS or in Tomcat or whatever you choose to run it in. The choice of application hosting technology isn't that important. The important parts are the geo load balancing component and the shared data backplane. So we can see here, I only have one backend pool and one routing rule. And what that means is, as far as front door is concerned, everything is the same website. It's just geographically distributed. So we can see here, we've got geodemo.azurefd.net. And if people want to go and open this in the background, please feel free. So you can do this. And all you should see is the resulting health probe coming back from ASP.NET, which is this. Yeah, so backslash just has a health probe, which returns the word healthy. Yep, nothing more. And you will be rerouted to the nearest region. And if you're interested to know which one that region is, please feel free to drop this in the chat window, by the way, if anybody wants to. We can go to API and Geode, which is the screen I just showed you earlier, and you'll see this Geode ID, Geode Demo App UKS. And if you're based in the UK or Western Europe, then that should be routing you to UKS. I don't know how many people in here will be based from outside the UK, but I'll show you how that shows up externally to the UK in a moment. In fact, let's go do that now. So this website, one I particularly like, actually, it's no endorsement from us, but this is just quite handy for testing stuff in terms of GeoPico. I can bang a URI in here. And what it will do is it will try and render that page from 6 different locations. There are other versions of this page you can do, so we can see where this has been looked up, and it will show us the output. So we can see which regions are rendering which location from where. Okay, and we would expect, in terms of where Ireland is located, for it to be rendered from the UK here, because I don't have a EU North or EU West. Thank you, Toby, for posting that in the chat window. Please feel free to go and do this as well. Go and open it up as we go and follow along. But look at the latency level here for the ping time. And that's a feature of the split TCP connection. Yeah, so 2 milliseconds, 4 milliseconds for California, 9 milliseconds, 19 ms for Australia. If we click on Australia, then we can see that's been rendered from Australia East. If we look at Virginia, oops, click. If we look at Virginia, then we can see that's been rendered from US West too. And if we look at Brazil, that's been rendered from US West too. Now, in particular in Brazil, I'm never quite sure where it's going to render from because it's roughly equidistant from London and Seattle. So it could render from the UK, it could render from the US. It depends on what the probe time of the nearest POP is showing at. So this is one of the things, if you use this with Traffic Manager, you get fine-grained control. If you want to do geographic routing, and instead of doing lowest latency, you can in fact change the profile to say route from the nearest endpoint or fix a locational endpoint. Because then you have Traffic Manager controlling where the routing is for the nearest AFD POP. Any questions on that before I move on? I mean, Singapore, you'll expect to see it routed from Australia because obviously it's APAC. I think we've been through the others anyway. So any questions on that before we move on? Oh, okay. Cool. So let's switch back to what we can see in here. So I've got a front end host here in terms of what we can see in front door, and that's my addressable domain. Everything comes in through this particular front door. And I have a default pool here for my backend. So I can have lots of these if I want to, and I can have lots of routing rules. But effectively what you can see here is these are my backends that are being configured inside this single pool. And each of those has equal weighting and equal priority. So front door will basically select from the lowest latency entity and send your user there. If you want to, feel free to say, you know what, there's no smoke and mirrors going on here. You can replace an individual geode's address. So this particular CIND endpoint doesn't exist. So front door will be holding it offline. And the only reason I've chosen to use CIND is because I haven't deployed the geode for Central India yet, because I want to do that as part of our demonstration later. So in a moment, we'll light that up and bring that into rotation to show you how like template and script-based deployment works with geodes. It's not a very exciting demo, so I'm going to do part of it in the portal anyway, but I will run a script in a moment to actually deploy a geode out to Central India. One of the things which you do need to think about in terms of dynamic operations here is I can change this and deploy this immediately, but it will take time to propagate out across your estate. So that's the reason why I've already added the entry into the backend pool, but haven't actually deployed the site itself. So this will just keep it offline right up until it's ready to run. So we can look at AUSE. And that's of course healthy. API/geode, and you see the page, that one's AUSE. So you can go and hit these directly if you want to, and we can pop these into the chat window for you as well. Yeah, feel free to go and interact with these again. You've got and the endpoints are Australia East, so AUSE. You can see it's in the suffix of the first part of the FQDM. So AUSE, the CIND, which is currently down for Central India. There is UKS for UK South. There's RSA for South Africa. And what was the other one? I've forgotten what one I deployed now. Yeah, AUSE, CIND, RSA, UKS, and USW2. That's fair, yeah, which is Western US2. And each of those should just return you that JSON object saying, hey, here's where I am. So you can determine which user it came in from telemetry and diagnostic data. If we want to show where traffic's being routed in from, so one of the interesting parts here is we can say, okay, so let's say request count, and we can say, give me the sum. So I can see all of a sudden we're starting to get a few requests coming in now. Look, somebody's actually starting to run some. And let's say, give me the HTTP status. So I can see it gets a couple of 500s over here while I was testing. I've seen a couple of 404s, so somebody's giving it a little bit of a test there. Yeah, and I can see the majority of them are coming back as 200s. And we can say, okay, let's see where they all are. Okay, right now, so we've got some people in Ireland, some people in Australia, and you can see these actual connections. These are the tests that I'm running. So this was my GeoPeaker instance, yeah, was the test from the UK, the test from the US, the test from Ireland, the test from Australia, Singapore, and Brazil. And I can see that actual load coming in there and be able to break it down. Now, obviously that's not typical workload, but when you look at this, it actually allows you to see where the client country or region, where your users effectively are hitting it from. So I can say, give me APAC or LATAM and splice those out. So you can see we're load balancing at a quite a simplistic level, but that's quite a powerful pattern. So we know which endpoint we're routing to. We have a fair amount of control, and we can see dynamically what's coming in. One of the things I can show as well, we can see what the latencies are coming in on the back end. Let's go for average. So I can see here, look, you can see the latency actually interesting. It's gradually coming down here. So, but again, we can split that by the back end. So I can see the individual request latency and load on each back end. And that will tell me, you know, whether one of my geodes needs to be scaled out maybe, or whether it needs to scale in. And in particular, these are all coping reasonably well. Yeah, okay, we could get better latency, but at the moment, these are deployed on tiny little shared app service instances. So no problem there, but we can set up alerts and alarms against this data. and we can configure auto scaling to help us with that. But the one thing I quickly want to show you, so I should be able to see a backend health percentage look, and we've got reasonable request here, but if you take a look down here, this one, which is CIND, is at 0% because it's just not there. So we don't have a deployment. We're about to see a cleaner come in here with a vacuum, so excuse the background noise, please. Okay, and in a moment I'll deploy that. So we'll switch that in a second, deploy that instance in, and you'll start to see that gradually start to raise, and then the Indian location will come online as well. In fact, let's do that next. Okay, one of the common things, of course, because geodes are supposed to be all identical, it's very easy to deploy them with a template or a script. So what I'm going to quickly do now, I do have a script in here, which is create geode. It's not rocket science. This will create and roll up my code, will publish it, zip it, creates an app service plan, creates a web app, deploys my config and zip file to it, and will set some additional app settings, which one of which is that geode name based on some parameters, and we'll set up my Cosmos data as well. So my Cosmos connection string, which, if I'm completely honest, in terms of best practice, should absolutely be sitting in a key vault. But again, then I'd have to create a key vault entity in the region and deploy that as well. So for the purposes of simplicity, it's sitting inside a configuration string here. But best practice would dictate you stick that in the key vault and you authorize the web app to the key vault. Okay, so all we should have to do here now is say create geode.bat, and we should be able to go geode demo, which should be this, and then we expect the name geode demo app CIND. So the first parameter to this script is the resource group, which you can see is %1, being used as a -g parameter in the scripts. The second one is the name of the site, which is the Central India piece. And then lastly, the third parameter is the region we want to deploy to, which is Central India. And that will build up our code, publish it, create the new plan, and then we should start to see that light up and start to be able to actually receive requests on the Geode Demo app CIND site. So let's switch back over here in the meantime. This is the point where I hold my breath. Still not resolving, so that has either failed or is still running. Okay, yeah, we're still running. Okay, so that's created that now. It won't have deployed anything yet. We've created the plan. We're about to now go and create the web app as well, as you can see here. So while we're doing that, have we got any further questions about what you can see here, how that works?
Hi, Will.
Hi.
Can you hear me okay?
Yep, I can hear you.
Yeah, awesome. Hi, my name is Dushyant. Previously, mic wasn't working. So one of the things I always thought, traffic manager and front door can both manage traffic to the nearest region. But you did describe that you would use a traffic manager if you had to do that.
Yeah, okay, that's a good question. So yes, the traffic manager has more flexibility in terms of what you can set the traffic profiling to do. Whereas front door can do weighted distribution. Yeah, so if there's more than one region which has similar latency, yeah, you can use a weighting to do it, or it can just simply route to the nearest online one, but it will use latency from the nearest POP to do it. So it will do pseudo traffic generation. If your user is in Australia and there's an Australian endpoint, or there's one of a set of Australian endpoints, it will route the user to one of those. But because it's based on latency, if one of your endpoints is under particular pressure, then what you might find is the user gets automatically geo-routed somewhere else. Whereas front door actually has a geographic routing mode where you can say, for users here, send them there to that backend, and it will route them to the geographically nearest endpoint rather than the one with the lowest latency. Using them both together, so if you point front door at traffic manager, you get the benefits of the layer 7 network acceleration, and you can get traffic caching, but you can then use Traffic Manager to control the endpoint that they hit geographically and get the best of both worlds. Does that answer your question?
Yeah, it does. Thanks.
Excellent. Okay. The only thing you need to remember, actually, if you do that as well, is if you're using SSL, the host headers that you have to specify, because there's a little bit of CNAME jiggery pokery going on behind the scenes. You have to be very careful that you select the correct ones. Okay, so we now have, I'm hoping, a geode running here. So we've now got a Central India geode that's spun up and accessible. The one thing it doesn't have right now, actually, I should be able to go and just give this a refresh. The lag on here maybe isn't showing this update yet, but in a moment that if we let this refresh, you'll see that start to raise. But the one thing that's missing here, of course, is my backplane. So at the moment, there's no data region. So at the moment, it will be reaching to another region for reading data, because I'll need to enable geo-replication of my Cosmos data to the India region. And I'm wondering what's going on there, because why can I not see the correct components of that blade? Probably because it's still loading. Let me show you, while we wait for that to come back, for some reason that's not opening. Let me just quickly show you this API actually in flight, reading data from the different geodes. So the API we actually deployed, all I showed you was the geode endpoint, but this is actually a fully functional OData service that you can choose to go and deploy. And this will send me to the nearest region and retrieve data on a particular flight. So you can see that we pulled this piece back, and you can see in the URL, look, that came from UK South, not from geodemo azurefd.net. If I want to update one, I can send a put here. So let's say actually we can change con ID to 72. Fire that. Okay, so that write executed in UK South because I'm sitting in Reading. But there's no reason why I now can't say, let's run a query, because the same API is delivered everywhere. So this is just a get without authentication. Give me that geodemo app. Sorry, .azurewebsites.net. And you can follow along with this as well. So I've intentionally taken the security off from here. So that's UK South just running direct, but I can go away and I can now say, give me West US 2. He says, that's not the right URL. USW2, not WUS2. Let's run the whole collection back and see what's just happened there. Okay, so here I have a geode failing. So there's something wrong with that. So the geode's up. I'm returning a healthy probe, but for some reason it can't access the Cosmos instance here. So I'm not going to go necessarily into debugging what's going on with that particular piece, but we can say API slash. Okay, and so that's from Central India. Coming back, I'm not sure what's wrong with the US instance. I'm not necessarily going to go into that right now, but your probe realistically should actually check with connect to the service and pull back data rather than just return healthy by default. But you can see there that we can go and retrieve that. I haven't actually done anything to enable that. That's connecting out to the nearest instance. But what we really want to do, I'll just refresh my portal, is to turn on geo-replication for the data plane itself. So the data is accessed locally in the Central India region. And it is as simple as going and hitting that button and hitting save.
We do have a question in the chat box as well there, where from
Yep.
Toby.
Yeah, okay.
Touch briefly on TLS termination of AFD. Presumably it would need to be configured on AFD plus the app services in each geode.
Yeah, so it depends on where and how you want to enable that. So if you do it in the traffic manager configuration, so if you point AFD at traffic manager, then you need to make sure that the visibility of the app service instance is the correct domain that you expect. So using custom domains and host header configuration, you can pass that end to end. But yes, AFD will terminate the TLS connection and reestablish a new one. So it can actually proxy request without having to have the correct inbound custom domain. And let me just quickly, I'm aware we haven't got much time left now. So let me just quickly show this. So in here, I'm saying I want just this domain. So geodemo.azurefd.net, but there's no reason why I can't come into here and say, give me a custom host name. And host that, yeah. Now, in particular, this is already pointed on my blog to another Azure front door, implementing exactly this pattern in the back end between storage endpoints. But so you can do custom domains, and in that case, you're going to have a CNAME record here. If you're then terminating that, what's going to happen is it by default will send this. So it will resend the host of the inbound domain onwards. If you want to override that, then you can do it in the backend configuration. So here I've got backend host header. So if my Azure website isn't listening on geodemo@ause.azurewebsites.net, if it's actually listening on www.willeastbury.com, and I delete that, it will specify the ingress route. So you can be flexible in what you want to configure with the host headers that you need. But you only have to configure the termination in AFD. Whatever you want at the back end in app service is what you need to specify how AFD connects out in your backends. Now that's important because there's quite a major misconfiguration we see when people do this. In fact, when people do proxies in general in Azure. And if you see people starting to override host headers, you need to be very careful about authentication and redirects. So if you get front door acting as like a translation of addresses, then what usually happens is if somebody has to log on with an OAuth token, say AAD, maybe Azure AD Easy Auth in app service could do this, we'll send back a redirect, but it won't send back a redirect for this domain. It will send back a redirect for this. Yeah, so the user will move off the geode and hit a single aligned instance. Now, in some circumstances, like the circumstance we mentioned earlier on, where you want to keep a given user's data in a given geography, but have a shared service that redirects them to wherever they need to go, that can be quite useful. But in 99% of circumstances, it's not useful. So you want to be careful if you have to override the host header for any reason. Okay, we've got another question from Jonathan Hughes. Missed first 30 minutes presentation, apologies, it was covered. Are there any gotchas to doing geo-routing via Azure to systems hosted at different cloud providers? No, in all honesty, it's not uncommon to see front door routing across a multitude of services. So front door is just a layer 7 distributed proxy. It can connect to whatever you want to connect to. That could be on-premise. It could be, okay, specifically, yep, no reason why you can't do that. Dapper's like just a sidecar sitting inside Kubernetes, whatever you want to do. What you'd probably do though is you'd probably point it at ingress in terms of Kubernetes context. So something is going to be fronting your Kubernetes clusters that is going to be hosting that, and each Kubernetes cluster would then become part of your geode, or at the very least, a set of pods might be part of your geode with an ingress. Jonathan, does that answer your question? Cool, excellent. Okay, so we now have kind of completion of the Geode demo, and I'm kind of out of time. We'll refer you to this particular document, which is up on the Architecture Center, which goes through what I've talked about. I've talked about it in a bit more depth. It will talk about why you might choose to use it, when you might choose to use it. What I've really tried to go through is why we created the pattern in the first place and wrote it up and how to implement it. But for further reading or viewing, there is video footage in here as well. One of the nice things that you might see, so the Geode pattern document at the top, there are some real world implementations of this. The first link here that you can see, this high availability with media services, is the media services team picking up this pattern and showing how you can implement HA for video streaming using this pattern. The SAP Where Can I Get Toilet Paper is actually what we originally created this API demo for. So this is an example of fronting a globally available service that reads data and caches it from an SAP platform system. So a surge in traffic doesn't take down your ERP backend, and you can actually accelerate in geo-rooted environments using Cosmos and a web API. The Geode Pattern Accelerator is a nice canned example. We also have the Cosmos team's documentation about building geo-distributed applications, which is the majority of this. As you're probably gathering, if you want all geos to be equal, you have to have a multi-right strategy. And the only real service that will do that is Cosmos. I would also encourage you to go and have a look at this GitHub repo here. So this is created by one of my colleagues, and this is a really nice demo application. So that if you look up on the Azure Architecture Center for this pattern, you'll see a link to this repo, actually, and that's the one that has the SignalR callback. So I can initiate a message in one region, let Cosmos replicate it, fire the SignalR instance to talk to another user or a set of users in another region using Cosmos as a backplane. I haven't demonstrated it today because it is quite complex to explain and we haven't got long, but it's pretty slick demonstration. And then lastly, if you want some more video footage of this to consume at your leisure, we have got recording, but there's a Cloud with Chris episode, where I talk with Chris Reddington about hands-on with this, and it's very similar to what you've just seen, but as a reference you might want to consider that. Okay, one last question. So Blazor server uses SignalR. Do the long-running sockets use yeah, great question. Yes, they do, frankly. As it stands now, not all of our services will run WebSockets, and I think Front Door is one of the ones that will not because of the way it proxies connections. I think it's on the it might be in an early preview stage. I'm not sure. I'll have to go and check that. It's been a while since I've looked. But SignalR itself tries to fall back to various methodologies if it needs to. So if you point SignalR through Front Door, what you're actually going to get if you're using a serverless pattern against it is you'll get a redirect to a local instance. So you'll have a SignalR instance in each region. gRPC is also Toby, yeah, absolutely. And so this is based around HTTPS plain comms. There are more advanced versions of this pattern as well. So you also wouldn't necessarily want to do gRPC in functions because functions uses gRPC internally. You would have no way to proxy that through. It's not necessarily the case of the long running socket piece. It's which supporting service you use to connect. Yeah, so the geo routing, you'd have to connect to the same instance each time, which again is okay. We can do service affinity if we need to, if you need to reestablish a connection. But your best way to do that is to have a gateway service in front and actually don't geo route the SignalR connection itself. You geo route the user so they connect to an in-region instance and then use the backplane to ensure that it doesn't matter which instance they're connected to, if they are connected, they still receive the message from all SignalR backplanes. So you actually put SignalR inside your geode rather than using a kind of geo replication technology. Okay. With that, I think we're probably out of time, maybe even a little bit over time, actually looking at the clock now. So I will hand you back to your host from IO. Thank you for listening.
Thank you, Will. Excellent, really good. So yeah, I hope everyone got most of that. Thank you everyone who did attend. It's really good. I know it was really sunny outside, so yeah, it's really good that everyone did get in here and and get involved. We do have a recording for everyone that came in late. I know I saw there was one of you came in half an hour, so yeah, we'll get the full video up, and that'll be out later in the week. We won't be doing a meetup in August as it's a school holiday, but we are in the process of getting speakers again. So by September, we will be back and no longer virtual, which would be great to kind of meet a lot of you guys and, just have that kind of normality back the way it should be. And as always, any suggestions for topics, speakers, things, things you've wanted to learn for a while, for example, get in touch with me or Charlotte on LinkedIn. Obviously, anything else you guys want to talk about, work related as well, do get in touch with us and with any questions as well. And we'd love to have a chat with you and see what you guys want to do next.